Popular night for a cold night. So nobody here is obviously watching State of Origin. So.
What's that?
All the nerds are here tonight.
Yeah.
Like to introduce my colleague from work, Raf. What he doesn't know about maritime radio isn't worth knowing. He's been in the industry for a very long time, 20 years at AWA, 24 years at our current workplace.
Yep.
According to your LinkedIn.
Yep. Okay, that gives out all the secrets.
All the secrets?
Yep.
Over to you.
Yep. Well, just after Malcolm's introduction, I mean, I started in this industry in '79 when I got an apprenticeship with what used to be AWA Marine. In those days, they were the leading electronics company, or AWA as a whole. But the marine industry, part of it was AWA Marine. AWA used to supply radio operators to all the Australian vessels, and also they used to have radio equipment. You know, the complete radio stations were supplied on contract by AWA. AWA used to then maintain the equipment. Anyway, Electrotech's come along.
Timber boat called the Mealy down in Rushcoa's Bay.
Yeah, the Demealy 1 or Demealy 2?
Well, they had two. The first one was a Halverson that I knew. Then they had a Sesquilty, slightly bigger boat.
Yeah, because the first one got sunk by one of the ferries.
I remember that. That's right. I'd forgotten, but I now.
Yeah, it didn't give way to one of the ferries just off.
That's right.
Where was it?
Doesn't matter. But yeah.
Doesn't matter. Anyway, they had some dignitaries on board. You know, windows all fogged up, and what next thing you know, didn't give way. Bang, down she went. So the rest is.
Embarrassing, wasn't it?
Yeah, very.
On that trip,
yeah, but it's and we had to sort of pull the gear off once she come out of the water. I try to salvage this, trying to salvage that, and not when it's had salt water in it. But yeah, okay, but you know, sort of progressed from AWA across to Electrotech, and I'm still doing the same sort of work. Yeah, just quickly, I mean, GMDSS, which is a Global Maritime Distress and Safety System, is basically an automated replacement for what used to be on board ships in the old days when you used to have a radio operator dedicated, to operate the equipment, the radio equipment, as far as listening for distress and traffic, and also, being, part thereof if in the event of a distress, obviously operating the equipment and, calling out for help and that. So, excuse me if I sort of look at my notes, but anyway, GMDSS basically connects you to coast stations and other vessels via satellite and radio communication when you're out at sea. It's taken away the radio operator because you don't have to have someone dedicated there listening to on the radio equipment. Everything's fully automated. The equipment just sits there, maintaining watch. I better start reading some of the. You jumped across to the Radio Surveys.
Oh, continue with whatever you want.
But anyway, it's okay. So before GMDSS, the SOLAS Convention required all ships, irrespective of their size, to carry a 500 kilohertz Morse telegraphy equipment and a VHF radio with channel 16. So that was your basic equipment. And also on top of that, it used to have a 2182 transmitter for distress purposes. Mind you, the radio equipment would have other frequencies as well that it could operate on, but basically for distress you were limited to 500 kilohertz Morse, 2182 voice, and channel 16 on VHF. So your range was limited. So the best you could hope for was contacting a nearby vessel, and that and it's certainly minimum operating range would have been about 150 nautical miles or thereabouts. So the limitations was short range, was all manually alerting, and you had to have someone listening out as well. So it wasn't like the equipment would automatically pick up a distress. You had to have someone physically operating the equipment and also maintaining watch and that. Now, with the introduction of GMDSS, in Australia it was introduced around about 1992. It went global at about 1999. So the first vessels in Australia to get upgraded were the coastal vessels, and then after that, a short time after, the international vessels were equipped with the new equipment, and basically with the GMDSS, it automates watch keeping. It removes the requirement of the ship and shore operators to maintain manual listening watches on distress frequency. So it's sort of you don't need someone on board the ship to do a continual watch, and likewise you don't need someone on the shore side to do the watch as well. The equipment that's forms part of the GMDSS, again, I don't know if I mentioned, it's a global maritime distress and safety system. Comprises of, you can have an Inmarsat terminal, which is basically a dedicated message terminal, an antenna, communicating with the satellite. It's L-band? L-band 1.6, 1.5 to 1.6 gigahertz. Basically, it's transmission of data, to and from, basically, from the ship to the satellite, and vice versa, through to the land-earth stations. I don't know if you've got a screenshot of the
around the slides.
Yeah, that one there sort of may sort of be a good representation. So we start with as I said, Inmarsat Charlie would relay to the satellite, and then back down to one of the rescue coordinating stations, and then any rescue coordination would be sort of set up from there. One of the things with the Inmarsat C is it will also they receive meteorological warnings and forecasts, search and rescue coordinating messages, as well as urgent maritime safety information, just any sort of information for the area that the ship's located in. It's also got the facility, like with all the GMDSS equipment, it's got a button on it, distress button. Obviously, if the ship's in dire straits and you're about to abandon, you press the distress button. It sends a transmission out to the satellite giving your exact position, and obviously the ship's details. That gets relayed down, and off you go. So that's one of the things on board ships these days. You've also still got your MFHF radio, but now with the MFHF radio, as well as voice, you have digital cell call, where the digital cell call terminal is programmed with the ship's identity, which is a 9-digit maritime mobile service identity number. So that identifies the ship, and you can send a DSC call from one vessel to another, for just general establishment of communication. If you want to sort of request that they sort of tune to a specific voice channel, to.
You have to have the digital call. Like there's no one listening until they it's opened up by cell call, isn't it?
No, well, it's you've got it's an inbuilt with the HF radio these days. It'll have a DSC watch receiver inbuilt.
Yeah.
So
what I'm getting at,
yeah.
you can't get on the radio and call anybody with a voice because no one's listening.
No, I mean these days no one's maintaining watch. So it's basically you've got to sort of establish a circuit, to sort of call the vessel via cell call.
Yeah.
And that's the same with VHF as well these days. I mean, with VHF, you've got, depending on the configuration of the vessel, you can have either a dedicated one channel, on 2187.5 kilohertz, or, if you go to another option, they have a 6-channel scanning receiver running in the background, which 2 megs, 4, 6, 8, 12 and 16. I won't bore you with the exact frequencies, but
put a call out on 7045 from a ship once or twice.
Oh, really? Okay.
No one got back.
yeah.
For various testing.
But if somebody's listening on that frequency, they can still hear it, can they? Even though
Well, it's you won't hear it because the receiver is just an inbuilt receiver that is running in the background. I mean, you've got with the HF radio, you've got the basic radio itself as far as voice, which you can sort of set up on whatever you like, whether it be a maritime frequency or listening to the races or God knows whatever you want to do. But in the background, you've got a dedicated receiver running off a separate antenna, which maintains watch on the digital cell call frequency. So different frequency. So and then whether a distress comes in or whether a call direct to the ship, for response. The receiver in the working in the background will pick it up, and then it'll sort of flag up an announcement, like a buzzer going off. Boing. It's a text comes up on the display, or alerting you to the fact that someone sent you, and it'll usually come up with the other vessel's ID as well. It's more, with VHF that you would use that facility, sort of contacting one vessel to the other. Like again, no one sort of unless they're maintaining watch on a specific channel, you possibly won't get hold of them. So the easiest way is, if the vessel that.
Are they still required to have it on channel 16?
Yeah, channel 16 and 13 for the for the harbour harbour control.
there is the
And that-
DSC on 16 as well.
Sorry.
Yeah, I know. Yeah.
The DSC on VHF is channel 70. Again, it's a receiver sort of inbuilt into the radio that's running off a separate antenna that you wouldn't even know it's there. It's just maintaining watch, for in case a call comes through on that frequency, whether it be a distress, from another vessel, or just someone trying to get your attention, that they want to have a word with you or whatnot.
The radio has 2 antenna connections.
Yep.
One's transmit receive, and the other one is
For the dedicated DSC watch antenna, basically, So you've instead of having one VHF antenna, you've got 2 VHF antennas.
So when you press that emergency button, the red button on the transceiver, on your syncing, where does that transmit to?
It just
Everywhere.
It'll just basically transmit within range.
And it's a
So-
cell call type of thing, is it?
Sorry.
It's like a cell call thing that just...
Yeah, it's a digital cell call, a selective call. But then again, when it's a distress, it just everyone in the area will.
With your MMSI number and your location.
Yeah, it'll give you an MMSI number. It'll give you location and the fact that you've in distress, and that if it was a selective call, then only the station that you're calling would receive that call.
And so when the people are receiving that, does it just come through the radio automatically, or?
The radio will just alarm. It'll alarm. It'll certainly if you have a distress call coming in, the thing will sort of give off a particular tone, and a visual.
It's not on every radio though.
No, you need to have a radio that's got we've got a DSC.
Fair slice of them do. I've had one for probably 10 or 15 years, and I've never heard an alarm. So if it went off, I wouldn't know if it was my bilge level water or what. You'd have to scratch your head. So
Yeah,
People don't press the button, they just call Mayday.
exactly right.
Yeah.
And it's probably worth mentioning too that the $300 VHF radios you buy don't have two antenna sockets.
Yes.
Yeah. See,
That's a pretty fancy radio.
Yeah, the other thing is you have different types of VHF DSC. You've got your fully SOLAS compliant ones, which have got two antennas, so you're continually watching channel 70, irrespective of whether you're making a call and occupying the the transmitter.
Yeah.
It's still listening. Whereas you've got the basic, just pleasure boat ones that share the common antenna. So if you're talking,
Yeah.
it's obviously not listening because it's switched the watch receiver out.
So Raf mentioned SOLAS, safety of life at sea. That's the rules.
Yeah, that was.
You'd know all that, Mel.
Yeah, like the back of my hand.
Yeah.
Oh my God, what's that?
You're not in the wrong way, Mel.
Yeah.
Keeps it under his pillow.
Yeah. But again, sort of going back to SOLAS, everyone would be hopefully familiar that that was after the sinking of the Titanic. That's what sort of kicked off, the SOLAS, which was the precursor to SOLAS GMDSS.
It's Rob's radio room.
It's
Yep.
the Titanic.
Yeah. Spark. Yeah, that's going back.
That's like home.
Yeah. So, but anyway, the.
So you're still using a synchronous spark gap transmitter?
Not quite, not these days. Yeah. God, those are the days when you used to have to manually tune radios. I mean, in those days I used to get the Sparky to, any time I'd go down on board, to sort of do a radio survey, to check the equipment. The last thing I wanted to do was actually try to tune up a transmitter. So, it was Sparky's job. Okay, tune up on particular frequency, and just, and I just do, check that it's, got the right meter amps.
Yeah, we used to get sometimes 30 amps aerial current on 500 kilohertz.
Wow.
Yeah, geez. Yeah, last thing you wanted to do was get an RF burn as well. That was the other.
That sort of it, yeah.
Yeah, no, it's yep. But that's in those days it used to be the way we used to sort of calculate. There wasn't really a power reading. It was the meter amps, which was
above the sea, and
and that's it.
Current.
Yeah.
That was Australia, but in Japan they'd send a vessel with a field strength meter and do a plot. A much
More thorough way, yeah. But that was it. I think the higher your aerial was, the better meter amps you used to get out of it. And that was the thing, trying to achieve the right readings. Anyway, so getting back to where did we get to? We've talked about the VHF, the HF. Again, same sort of principle as I was saying. It's you can have voice, and you can have digital cell call. Again, it'll have if all else fails, you've got the distress button on the front of the radio, which you hit the button and it'll send out a distress call, and any vessel within the area should hopefully pick it up. With the advantage of the Inmarsat one, obviously it relays straight back to the up to the satellite. So regardless of where you are, you don't have to sort of rely on ship to ship, or someone nearby. It's just basically straight up to the satellite, down to the closest.
There are Inmarsat terminals on the left and right.
Yeah, so that's basically it. I mean, it's the modern day units. It's just telex over satellite, basically, as far as the operation. You can sort of send emails, sort of small emails, or but the bulk of the messages that you would send if you were sort of using it to send back to the head office and whatnot. You know, it'd be short text type messages. Again, the Inmarsat sees, as I mentioned before, they basically receive enhanced group calls. So any sort of warnings in the nav area that you're sailing through would come up in the receiver. You'd get a pop-up message on the screen, obviously saying, "Hey, you've got a new message come in," and you just go and check what it is, if it's relevant to yourself and that. They're all stored in a log these days. It's gone are the days where you used to have a floppy disk for storage of the messages. That's a typical HF radio control unit. Anyway, that's only the control head. The transceiver obviously is a much larger part of it. It's not shown. But getting on to the configuration on a ship these days, you would have, for redundancy and you have duplication of systems, to a degree. So you'd have two Inmarsat C systems, a primary system and a duplicate system. Likewise with the VHFs, you'd have a primary and a duplicate VHF. You'd have charging system. The equipment runs both off the ship's mains, and in the event of a blackout, it should operate off the ship's emergency generator. If all hell breaks loose and you lose that as well, it defaults over to emergency 24-volt batteries as well. So you've got, a fail-safe, that you should have power at all times, and then depending on the vessel, with the to comply with SOLAS, you need to have enough battery capacity to operate the equipment for a duration of an hour. If the emergency generator is below the waterline, then it's 6 hours, obviously, because if you have some sort of major problem, the ship takes in water, emergency generators below the waterline, it takes in water and it gets damaged. So you need to have, in that event, if the emergency generator is below the waterline, automatically the batteries have got to have enough capacity for 6 hours instead of 1 hour. Additional bits of equipment which aren't shown there. You also have a Navtex receiver, which basically that's a typical old one. It will receive maritime information on MF frequencies, 518 kilohertz. What was the other one? I forgot that. I should have remembered that one. Where is it? The 490. Okay. I mean the common one's 518, 490, and then you've got the 4209.5. So in areas that have Navtex transmitters and Navtex service, you'll receive similar messages that you would receive on the Inmarsat C. So obviously via over the air rather than through satellite. So international voyaging ships, it's mandatory to have a Navtex receiver. It's just FEC broadcast, that's being sent to the receiver. Additional equipment. You have radar transponders. Basically, that's it operates on the 9 gigahertz frequency, so that'd be your X-band radar. What happens if you activate this? It'll be listening for a radar transmission. So if it gets pinged by a signal on the 9 gigahertz band, it'll resend that signal back to all and sundry. So, and within it's only a short range. It's about 15 nautical miles. And what would happen is the ships within range would see a series of dots on the screen, sort of pointing towards the location of the SART. So, I mean, in the event of the ship going down, what normally happens is you take the SART with you into the lifeboat, put it on a post, and sort of raise it as high as possible.
There's some people on a submersible that would like to have one of those.
Yeah, I don't know how it would work too well underwater. That's unfortunately. But
it's only 4 kilometres down.
yeah, but it's odd though. I would have thought, with those ones that have one of those beacons, like those pinger beacons, like we use for the voyage data recorder.
Beacon that goes onto a capsule on a ship. When a beacon gets submerged, it starts pinging for 90 days in ultrasound.
Is this like they use on so-called black boxes on aircraft?
Well, it's the same thing. It's a black box for ships. On a ship, it's a voyage data recorder, but it's effectively a black box recorder. And there's
their orange, so you can find them. But
yeah, I mean, basically what happens is you've got a fixed capsule on the upper deck of the ship. The ship goes down, as Malcolm said. Once the water hits the beacon, it'll start pinging, and then they just send down an ROV, to sort of locate the ship, sort of track the, where the signal's coming from.
There's 2 recording devices on a VDR. One's a float-free capsule, which is basically an EPIRB with a recording device strapped to the bottom of it.
Yep.
And if the ship's here we go. Here's one we prepared.
Well, this is a baby one. It's
the recording device will float with the EPIRB, and the other is the fixed capsule, which is what we were just talking about, which is attached to the monkey island or compass deck above the bridge, and that's designed to be released by an ROV once a ship has been located.
Yeah. So what Malcolm's talking about, this is just your general EPIRB, and the one with the recording device attached to it is a much larger EPIRB. It's got a physical piece underneath, which it gets the recording is via
it's a wireless
connection to the
between the recording device and the base of the EPIRB.
Yeah. So when that EPIRB is deployed, the recording device goes up with the EPIRB. The EPIRB goes off. It transmits on 406 megahertz direct to the satellite, built-in GPS. So they can locate within 20 metres accuracy if it's got GPS these days.
Yeah, or better even.
Yeah, so that's how they can retrieve the recording capsule.
Same like Raf said, the newer EPIRBs have a GPS and AIS, so they'll show up as a target on the ship's radar.
Yeah. So with AIS, it's automatic identification system, which there's 2 frequencies on VHF, which again broadcast the ship's MMSI number and other particulars. It'll broadcast the ship's name and whatever else is programmed into the unit.
I can't remember. Is that done on a VHF channel?
Yeah, it's 2 channels. Excuse me for not remembering all the time, but it was 161.975 and 162.025. So it's AIS channel 1 and AIS channel 2, and the same information is sent on one and the other sort of thing. And
also an audio beacon on airband.
All right.
Audio beacon?
What's that?
On the airband, the 1.2.
Oh no, okay, we're talking about EPIRB. Okay, sort of we've jumped.
Sorry, my bad. Didn't the 121.5 audio go out with pointy toe shoes?
No, the 121.5 still. It's still there. I mean, the very first EPIRBs, and this is going back to that other company, used to be 121.5 and 243 megahertz, the two aviation frequencies, and with the implementation of the current EPIRB, the first generation was 406 megahertz, for your satellite link, but then it still had the reserve transmitter 121.5 for homing. So when the aircraft vessel gets within range, they would be able to pick up the signal on the 121.5 and home in. So that's
still the case today, is it?
That is still the case. I mean, what they've done now is, obviously they've added GPS to sort of make it more accurate, and the latest EPIRB, which this isn't the one, it also has AIS. So it will, any vessel within range, it'll come up on their radar via the AIS receiver or transponder that's on the ship, which is connected to your radar. So a little triangle with the particulars of the unit. It'll show up as a triangle plus the serial number of the device. So that's with the basically one of those is incorporated in the latest EPIRB as well. So you've got multi-facets as far as the ability to sort of coordinate search and rescue. I was talking about the radar transponder before. You've got the alternative these days where you've got an AIS search and rescue transponder. So rather than sort of operate on the 9 gigahertz X-band radar frequency, this one operates on the 2 AIS frequencies. And again, so any vessel within range will their AIS receiver, which is integrated into the radar, will pick it up and obviously display it on their screen. So instead of getting a series of dots pointing in a particular direction, you'll get a physical point. That's where the vessel is. It won't identify the vessel because it's not programmed as such. It just has it's just a blip on the screen. It's got a unique serial number. Each unit has got its own serial number, and no 2 manufacturers will have the same serial number. So it's unique to that particular unit. I don't think they keep a registry of who's got what and whatever, but it's obviously if you sort of see one of these things going off, it's you need it's gone off for a reason. Yeah. If you're testing that, it has got a test facility, but it comes up as with a mark, saying test, But if you activate it, then it's you get a different message coming up on the screen. Obviously, when you actually click, that's what I meant to say. Is you you can select the target, and that's where the information will show up as far as the identity. It'll also report the position as well, because it's got a GPS inbuilt into it. And that's the differentiation. If you happen to see one coming up on the screen and you hit the target and it says test, it's someone carrying out a test, Radio Surveyor or someone that's on board, for the annuals and that. Other devices they have on board ships, handheld VHF radios. That's usually if again you're abandoning ship, you take the radios with you into the lifeboat, and that's your communication with the rescuing party. And that it's same channels as a normal onboard VHF. So you've got your emergency channels and just your general channels.
5 watts, right?
Sorry?
5 watts?
5. Some of them are 5 watts, but no more. Some of them come out with as 3 watts. The regulation is if it's above, if it's above a certain level, you need to be able to sort of switch it to below 1 watt. So so if it's if it's a 5-watt radio, obviously it'll automatically have a button on it to sort of reduce the power. Obviously to conserve battery life. You've got the rechargeable battery that the radio is normally fitted with, and I mean you've usually have 3 on board a typical vessel.
Are they typically, will they float as well as be waterproof?
To float to some degree, but I wouldn't want to sort of test it. I mean,
an icon which is similar to that, it's black.
Yeah.
And I was given it by a client, and he found it on Bunham Beach.
Okay.
They float.
And it
Right.
still works?
And it still works.
Oh, well, that's good. Okay. Well, the black ones are the non GMDSS ones. I mean, the other thing, they've either got to be yellow or orange. You know, that's one of the other requirements. You know, obviously they don't have a digital cell call. They have an emergency battery that comes with it, which is different brand. I mean, that's that's for a sailor radio. So basically, you've got your rechargeable battery and your one-use battery. So in the case of an emergency, you take those ones with you. When that battery runs out, obviously you've got the spare battery that you can use until it's depleted. Those batteries are valid. Regulation has it they're to be replaced every 5 years. So once 5 years is up, regardless of whether they've been used or not, well, you need a new set of batteries to be in compliance. Likewise with the SART, the batteries on the SART, their batteries are usually valid for about 5 years. After 5 years, you can have the battery renewed. EPIRBs, technically you can replace the batteries if the manufacturer were to sell you the battery. But
makes it worthwhile.
But the problem is if you need to do battery replacement, which is part of again, it's every 5 years. That is what would be called the shore-based maintenance, where the EPIRBs, pulled apart, the battery is replaced, and they do spec checks, really sort of critical checks on the unit, to the point where you need to have a screened enclosure to be able to operate the EPIRB in, so you don't have any sort of false activations, So it's cost prohibitive as far as the price of the battery, if you could get it, the amount of work that's involved to do the replacement and speaking of EPIRBs, they usually sit in an auto release cradle, and that's on the railing or some external part of the vessel within range of the wheelhouse. And anywhere where it's not going to get fouled, if the ship goes down, you don't want to have it where if the EPIRB goes down with the ship, it doesn't. Once it deploys, you don't want it sort of getting caught in any sort of superstructure and whatnot. So you want to have it away from everything. What the best idea is, grab it and take it with you, and that way you can actually they can sort of. When they send out the rescue party, they can come and look for you rather than the ship that's gone down. You've got 2 ways of activating the EPIRB. Manual activation, where you rip the tab off and switch it on, or if you just drop it in the salt water, you've got salt water contacts which completes the circuit and off it goes. You've got a lanyard which you can use to attach it to the life raft and sort of have it towing not far. Once it goes off, you've got a strobe light that sort of repeatedly flashes at regular intervals, to sort of obviously sort of act as a homing, a visual homing signal. EPIRBs, as far as programming, you can program the ship's MMSI number into it, and that way, if the EPIRB has been registered, which it's a common thing in Australia, not so much with other countries. there's a central database that's maintained, and they can easily identify, what vessel is in distress, and they should have the contact details of the owners or the operators. So, first point is that if an EPIRB's detected, they find out who the operators are, call them up, and just make sure it isn't a false distress. If it's that once they ascertain it is a.
I'll tell you a funny story about that. I used to sell EPIRBs at retail recreational boat level. We sold 10 to a fishing club. This is when 406 EPIRBs first became compulsory for boats going more than 2 miles offshore or something. And we sold 10 to a fishing club, and we said to them, look, we've got to register these to the person that's buying them.
Yeah.
Because part of the deal was you got 2 registration forms in the box. One was for the dealer to register it and send off, and one was for the buyer to fill out his details and send off. So they should be exactly the same details when they got to AMSA.
Yeah.
Now, that was all okay. The guy from the club came down, picked up the 10 EPIRBs with 10 names and addresses, filled out the forms, but then he went back and gave the EPIRBs out willy-nilly. Right? And one went off in the back of a bloke's car. And they rang the guy whose number, and he said, hang on, I'm not out in my boat. The EPIRB's bolted in my boat, it's not going off. And they had to ring around the 10 people.
To figure out who it was.
To find out who had one that was in the back of his car going off.
Yeah.
It had its problems.
Yeah, well, speaking of EPIRBs going off, the common thing is when the battery runs out, people have been known to sort of dispose of them in the general waste.
Yeah.
And we've...
The bulldozer turns them on,
yeah, and we've seen them where it's absolutely destroyed. The antenna's broken off and whatnot. It's out under mounds of waste, and it's still...
Doing its job.
Doing its job, yeah. And you've got AMSA, coordinating a rescue into the local tip, and at great expense. So the thing is, before you dispose of an EPIRB, disarm.
Just pull it apart.
Pull it apart. Pull the battery out. Break the circuit board even. So no one's going to sort of cobble the thing together, and create havoc.
We used to send them all around the country too, and we put one in a box right next to a set of radio speakers with a big magnet in it. Must have had a reed switch in it that turned it on. Yeah.
That's weird. Was usually the magnet supposed to stop it from going off? Was that you've got a magnet there, and that's obviously the reason for that being that once it's in there, if you've got salt spray and whatnot, and you dirty up the case, you don't want the thing.
The very early 406s, and
it went off.
The magnet set it off. So
yeah, well,
the magnet might have cancelled out the magnetism in it.
God knows. But anyway, if this were to go down with a ship, the hydrostatic release, it's about 2 metres, 4 metres, say, once the vessel drops down to that level, the pressure of the water will activate a diaphragm. There's a spring inside here with basically a knife blade, and that will sever the rod. Once the rod's severed, that'll push the EPIRB and the cover off. The EPIRB's got a weight in it which should help it break away from the EPIRB. The EPIRB itself would float up to the surface. That's if you haven't managed to grab it in time. Yeah, and it will once it's away from the cradle, it automatically activates and starts transmitting. Yeah, and that's what Malcolm was talking about. That's the capsule for the voyage data recorder, or black box. It's a much larger EPIRB. It's usually
same mechanism, so that eject itself.
Exactly, same manufacturer, Jotron, but regardless of the manufacturer, they all employ the same sort of arrangement where you've got a hydrostatic release, shearing, a plastic pin. speaking of which, I've seen sometimes where someone's replaced it with a steel rod, but we won't, go there. You know, the things. It'll eventually, yeah. It's the things you see when you're doing a radio survey.
Iberian registered.
Yeah, but I mean that's basically it. Yeah, that.
No, just to change the subject.
Now changing the subject. Okay, I mean one of the things that we're required to do, you've got with obviously with the equipment on board, it needs to be checked annually as part of what we call a radio survey. Each vessel is registered under a different classification society. Now, classification society is basically an organisation that go on board. Marine surveyors. They check the vessel, to make sure that it's fully compliant. There's no deficiencies as far as construction, machinery, whatever, all that sort of stuff. Basically, it's a prelude to the ship getting seaworthiness and insurance. Now they do the inspection as far as the construction and all the other things like that. Obviously, the radio side of things goes to people with experience in that area. So the likes of Electrotech, we've got qualified radio surveyors who go on board and check the equipment, make sure it's working correctly. Check the VHF radios, for instance. We've got these days testing is a lot easier with a device that does a multitude of checks. It can check the EPIRB, decode what the EPIRB transmits, just to verify that it is programmed correctly and it's operating correctly on all the valid frequencies. You can test the SARTs with it, handheld VHFs. You can send DSC calls and receive DSC calls, both to the VHF radios and the HF radios. So basically, you can sort of confirm that everything is functioning correctly. And that's the easy part. The pain in the posterior is then filling out their paperwork. That's the once you've done it. Oh, thank you. Cheers. Excuse me. Yeah. So basically, we go on board and just check that everything is as it should be. Make sure the equipment has been maintained. We do a battery test on the emergency batteries, supplying power to the GMDSS equipment. We just make sure that the battery voltage is above a certain threshold. Normally we do a 1 hour discharge at 30 amps.
They're big batteries.
Big batteries. I mean, they're usually, as a general rule of thumb, you're usually dealing with 24 volt, 200 ampere hour batteries to have, the desired capacity for, to operate the equipment. But, so hitting it for...
lead acid or lithium these days?
Still lead acid, mainly sealed lead acid. They've sort of gone away.
Not regulated jobbies.
Yeah. I mean, these days, with the open cells, those, no one maintains them these days, so they put maintenance-free ones and hope for the best. The number of times you'd go on board a ship and they'd have the open wet cells and the electrolytes down, and you've got to top it up before you can even do any checks on it. Yeah, I mean that's one thing. Once they got rid of the Sparky on the ship, the maintenance went out the window. Yeah, so I mean that was one thing. It's with radio operators, the only time going back to the AWA days, the only time that we got called down to a ship was when Sparky couldn't fix it, and usually they'd given it red hot go and that on the gear. But these days, maintenance is a failing thing. Even the vessel. The casing and sort of leads to water ingress, and then you've.
Was this still sort of semi-functioning?
No, it had failed, and they were wondering why it had sort of failed. And yeah, I mean, luckily, the problem is, once you start getting water in the coax, usually, you've got big problems. But thankfully, that had a loop in it, and it hadn't sort of.
It happened early enough.
Early enough that it didn't sort of. Maintenance of.
Is that centre terminal there a copper strip? Is it? I can see the one.
There's
like a PCB.
It's the circuit board, yes.
That's a circuit board. That's the other end of what Malcolm had earlier on in the piece. Mind you, the other thing is at this point here, which you can just barely see, there's an earth point where normally you'd hook up a. Does
that just connect to the hull of the ship?
Yeah, that's it. You need to sort of have it for a ground reference as short as possible. Otherwise, you get again tuning issues. It's not.